Hey there, and welcome to today's Explainer. We're jumping right into something that is literally revolutionizing the water purification industry. Today, we're taking a deep dive into the technical advantages and patent innovations of plastic-sealed brushless DC, or BLDC pumps. Specifically, we're looking at the game-changing tech from Sanjiao and their renowned E-CHEN brand. We're going to see exactly how this plastic sealing technology radically improves both efficiency and reliability. So let's start with a basic question. What actually makes a modern water purifier truly smart, silent, and, well, unstoppable? To get the solution, you kind of have to understand the problem first. Think about traditional brushed motors for a second. If you've ever had to deal with them, you already know the headaches. They're bulky, they're super noisy, and honestly, in a water purification setting, they are incredibly vulnerable to moisture and oxidation. To fix all that, you can't just tweak the design a little bit. You need a complete rethink of how the motor is built from the ground up. To break this all down, here's our quick roadmap for today. First, we'll meet these plastic-sealed brushless motors. Second, we'll look at the massive leap in performance and reliability. Third, we'll crack open the core patents and tech. Fourth, we'll see how they hold up under rigorous testing. And finally, we'll tie it all together with smart water purifier applications. All right, let's jump right into part one. Meet plastic-sealed brushless motors. The absolute secret sauce here is BMC plastic encapsulation. Think of the motor stator core and those intricate wire windings as its vital organs. Now imagine wrapping those vital organs in an impenetrable suit of armor. That is exactly what Sanjiao is doing. Instead of a traditional metal casing, they use an integrated molding technology with BMC composite materials to entirely encapsulate the motor. And this isn't just for looks. This solid armor completely locks out moisture. It totally prevents the air oxidation that usually destroys wiring over time. Plus, because the material is so incredibly rigid, it naturally suppresses vibration and noise right at the source. It's a massive upgrade. And the physical result is just sleek. When you look at the highly compact EC BLDC FT1600A series pump, you can see it right away. By ditching that clunky old metal shell and using this BMC encapsulation, the engineers have managed to create a design that's significantly shorter and way lighter than standard motors. It's just a beautiful, compact piece of engineering that saves absolutely crucial space inside modern home appliances. Okay, moving on to part two, the leap in performance and reliability. When you actually stack this plastic-sealed BLDC technology up against the old-school motors, the numbers just blow you away. I mean, a standard induction motor, that's going to give you maybe 25 to 50% electrical efficiency. A brushed motor does a bit better, bumping it up to between 65 and 75%. But this BLDC tech, it consistently hits an incredible 75 to 88% electrical efficiency. And on top of that, it gives you stepless speed regulation, which is something those older models either really struggle with or literally just cannot do. But honestly, if you only remember one number today, make it this one. Greater than 10,000 hours. Think about that. Traditional brushed motors rely on carbon brushes that constantly wear down through physical friction, meaning they usually completely fail before they even hit the 3,000-hour mark. But because this BLDC motor is totally brushless and locked inside that protective plastic-sealed armor, its lifespan just skyrockets past 10,000 hours. It is the ultimate proof of long-term reliability. Let's get into the brains of the operation. Part 3. Core patents and tech analysis. What really sets this apart isn't just the hardware, it's the proprietary software and control systems. For instance, Sanjiao holds patent CN1885561B for their diaphragm booster pump control system. This is not an off-the-shelf part. They've developed their own field-oriented control, or FOC, smart algorithms. This acts as the motor's brain, allowing the pump to dynamically adjust on the fly, while completely protecting the entire circuit from things like overvoltage, undervoltage, and dangerous temperature spikes. And when you look closely at the internal components, the 3D structure of the controller housing next to the highly integrated circuit board, you realize just how much power is packed into this tiny space. This incredibly compact controller is exactly what enables that stepless speed regulation we mentioned. It seamlessly ramps the motor all the way up to 1950 RPMs, it easily manages pressures from 0 up to 150 psi, and it can accommodate a massive power input range from 85 to 265 volts AC. And here's the crazy part.
While it's doing all that intense, heavy-duty computational lifting, the variable frequency drive controller itself operates at over 95% electrical efficiency. That means almost zero energy is wasted as heat. Pretty much every single drop of power goes directly into perfectly controlled pumping action.
They've also totally solved one of the most annoying persistent failure points in the entire motor manufacturing industry: the wire connections. Check out the 3 steps of their patented piercing terminal connection process. Instead of relying on a fragile, traditional copper-aluminum weld that can easily snap or corrode, this terminal literally bites down and pierces the wire. It creates a permanent, mechanically secure connection that completely eliminates those old failure points. It is just a brilliantly simple fix to a really complex industry headache.
Next up, Part 4, Quality Under Rigorous Testing.
Now, you might be wondering, how tough is this armor really? Well, these units are pushed to their absolute breaking points in the lab. We're talking surviving 1.2 megapascals of static pressure for 5 straight minutes without a single deformation. They have to endure an agonizing 100,000 consecutive water hammer shock tests. They secure an IPX4 waterproof rating, ensuring they are completely safe even in super damp environments. And they're run continuously, non-stop for up to 1,500 hours at high flow rates, just to absolutely guarantee they won't overheat or leak. When you compound all those extreme tests together, you end up with a pump you can trust implicitly. Finally, let's talk about the real-world impact. Part 5. Smart Water Purifier Applications.
So what does this actually mean for you and me at home? Because of that ultra-smart FOC brain and that tough BMC armor, this pump isn't just moving water around. It literally acts as the nervous system of the whole purifier. It allows for seasonal automatic adjustments, intuitively changing its speed depending on whether freezing winter water or warmer summer water is flowing through the pipes. It easily manages distinct flow rates for cold, warm, and hot water modes. And this is wild. Through dynamic RO filter monitoring, the pump's brain can actually detect tiny, subtle current changes when the filter starts getting clogged, automatically triggering a replace filter alert. And thanks to that encapsulated design, the whole shebang happens almost completely silently.
Which brings us to our final thought for today. We are fully entering an era where consumers just expect their household appliances to be entirely autonomous, highly efficient, and whisper quiet. So, as you design or invest in the next generation of these tools, you really have to ask yourself, is your engineering protected by the right armor and driven by the right brain? Sanji Zhao's plastic-sealed BLDC revolution is absolutely setting a new gold standard. Thanks so much for joining me on this explainer, and keep questioning how the tech around you is built.